Hello, I am Gert Willy from France, and my computer series. You are watching my computer lecture series, learning computer with seeing the natural side of or natural beauty of Indian village. In the previous lecture, we talk about the CPU, Central Processing Unit. It has two units, CU and ALU, and we see about arithmetic logic unit instruction set. Now in this lecture you know about the register, and so see what is registers. As a computer central processing unit interprets and executes instruction, there is movement of information between various units of the computer. To handle this process satisfactorily and to speed up rate of information transfer, the CPU uses a number of special memory units called registers. These registers hold information temporarily and are part of central processing unit, not main memory. Length of register is equal to the number of bits it can store. Hence we refer to a register that can store 8 bits as an 8-bit register. Most central processing unit sold today have 30-bit or 64-bit register. Some may be 28-bit. The length of registers of a computer is sometimes called its word size. The length of a register of a computer is sometimes called its word size. The bigger the word size, the faster a computer can process a set of data, with all other parameters being same. A CPU with 32-bit register can process data twice as large as one with 16-bit register. Similarly, a 64-bit process the data twice as 32-bit processor. So more bits means more processing speed. Although the number of registers varies from computer to computer, there are some registers common to all computers. Function of these registers are described below. Each of these registers possesses the ability to receive information, hold it temporarily, and pass it on as directed by the control unit. Now there are different types of registers. We see each one by one their importance. The first is memory address register, MAR. Memory address register. It holds the address of the activity memory location. It is loaded from program control register when the system reads an instruction from memory. Next is memory buffer register, MBR. It is also called MBR. It holds the contents of the accessed read, written memory word. The system transfers an instruction word placed in this register to instruction register. A data word placed in their register is accessible for operation with accumulator and register or for transfer to IO register. To store a word in a memory location, the system first transfers it to MBR and then writes it in memory from MBR. MBR means memory buffer register. I am talking about the memory buffer registers. Next is program control register PC. It is also called PCR, program control register, and it works is that it holds the address of the next instruction for execution. Normally, a system stores instruction of program in a consecutive memory locations and executes them in sequence unless it encounters a branch instruction. A branch instruction is an operation that causes a transfer to non-executive instruction. The system transfers address part of a branch instruction to PC register so that it becomes the address of the next instruction. Next, we know about the accumulator register A. It is represented by A or AR. Now it works is to hold the data on which the system has to operate intermediate results and results of operations performed. The system uses it during execution of most instructions. The system returns the result of an arithmetic operation to accumulator register for transfer to main memory through memory buffer register. In many computers, there are more than one accumulator registers. Next is instruction register. It is represented by I or IR. Now it works. We see it works. It holds the current instruction under execution. As soon as the instruction is stored in this register, its operation and address parts are separated. The system sends the address part of the instruction to MAR, as is memory address register, while it sends operation part to control unit, where it is decoded and interpreted. Finally, the control unit generates and sends command signals to the appropriate unit for carrying out the task specified in the instruction. And the last one is the input output register, I/O register. The system uses it to communicate with input output devices. An input device transfers all input information such as instruction and data to this register. Similarly, the system transfers all output information to this register, and an output device picks up data for output from here. So then this is the explanation of a register in computer system. Now we summarize the function of a register here. First is the memory address. Our memory address register written as MAR in capital letter, that is cap MAR, and its function is to hold the address of the active memory location. Next is second is memory buffer MBR, memory buffer register. It holds information on its way to and from memory. Third one is program control register PC, hold the addresses of the next instruction to be executed. Next is accumulator register AR or A, accumulates results and data to be operated upon. Next is instruction register or instruction IR, holds an instruction while it is being executed. And the last one is input by output or input output register, communicates with input output devices. Now the execution of an instruction by CPU during program execution normally involves following steps. The control unit takes the address of the next program instruction for execution from program control register. and reads the instruction from corresponding memory address into the instruction register of the control unit. Second point, the control unit then sends the operation and address parts of the instruction to the decoder and memory address register respectively. Third, the decoder interprets the instruction and accordingly the control unit sends command signals to the appropriate unit for carrying out the task specified in the instruction. For example, if it is an arithmetic or logic operation, the control unit sends signals to arithmetic logic unit. In this case, the control unit also ensures that the data corresponding to the address part of the instruction is loaded in a suitable register in arithmetic logic unit before it sends the signal to arithmetic logic unit. The arithmetic logic unit performs the operation on the data and signals the control unit as soon as it has finished. The last point is that as the system executes each instruction, it loads the address of the next instruction for execution. As the system executes each instruction, it loads the address of the next instruction for execution in program control register and repeats the previous 1 to 4 steps.